everybody. Today we will do another video, and today we will do what is called the dot product. It's a different concept, the dot product. So the dot product of two vectors, right? So it's called the dot product of two vectors. Okay, so this is the concept, right? This is the basically what we'll be studying, right? So this is the new topic. You can call it topic, right? New topic that we study. And so basically what it is the dot product is the multiplication of two vectors that the result would be in scalar, right? So basically it's a vector multiplication and addition, right? And addition, right? Of by a scalar, right? By a scalar, right? And notice that the result of this is going to be also on a scalar. A scalar unit, right? Oh, yes. So the result is going to be a scalar, right? So, so basically, when we say it's going to be a scalar, it's going to be just a number, right? So we talked about before that numbers like weight, time, anything like that, right, is a scalar number. It's just a number. It doesn't have a direction. But if I say velocity, right? Velocity is a vector. It's a vector. Why? Because it has a magnitude and also has a direction, right? Magnitude and direction. Right? If I say 25 miles per hour or 45 miles per hour, right? 45 miles per hour. Right? 45 miles per hour, actually, it's written. $45 miles per hour is just a scalar. Alright? Why? Because it's giving the rate. It doesn't give me the direction. But if I say 45 miles per hour north, 45 miles per hour, south, due south. That is a vector. Just give me the direction, right? Or, or I can say, 45 miles per hour in this degree, this how many degree, as long as I haven't got a direction, this will be considered at vector, but in this case, it's in a scalar. So the number that we will get when we do this problem is going to be just a number like that. That's what I'm trying to say. It will not have an angle. It will not have any other direction. It just will be a number. Right? So, so this is going to be very important to learn. This concept is very important because a lot of questions will be popping up in physics like this, right? So, okay, so the dot product is called basically the dot product is called because it has a dot in there, but it's a multiplication and division. It is interesting because eventually we will be doing some problems in another section. It's called the cross product. The cross product is a different topic. I will get to it. First, we will do the dot product, right? Okay, so the dot product it says the dot product yields a scalar rather than a vector. Exactly, that's what I said. It's going to give us an answer on a scalar, right? Not as a vector, right? So, okay, so the dot product, the dot product is usually like this, right? So the dot product is usually like this. So the dot product, these things are not really, okay, this is better. The dot product is usually represented by, we have already studied, right? We already have studied this, which is called U, right? Vector U is equal to V, you can call it V1, V2, right? V1, comma, V2, and vector V is also has V1, V2, right? So basically V1, comma, V2, right? So the dot product of this, right, is going to be equal to this term times this term plus this term times this term, right? So actually, this is U and this is V. This is U2, right? So then the dot product is going to be this times this plus this times this, which is going to be equal to U dot U1 dot V1 plus U2 dot B2, right? But technically, what they saying is that the rules, let me write them up here. So the rules are the following, right? So in this case, actually, they don't even have the dot. They're just multiplying. Don't worry about it. Just multiply. Right? Okay, so that is that, right? So, and then what they saying is that you, so in other words, you have more terms. Just do it the same way, right? So if you had more terms, if you have U3, V3, you do the same, right? So yeah. So basically that's what it is, right? So now I'm going to write the rules here. So basically this one right here, I can replace this with u dot b, right? U dot b is equal to that, right? So that would be number one. Actually, yeah, well, not number one, it's just basically the concept. But then in this case would be, if we want to do this, it's going to be u dot b is equal to u plus b is equal to u dot b, right? Yeah. So u is equal to u dot b, right? Then the second one is going to be u the second one here is going to be u dot v plus w, right? Which is equal to what? I gotta distribute this. I gotta dot this u, or this is, yes, I gotta dot this u. I gotta distribute that across, which is going to be u dot v plus u dot w, right? So in the next one is c dot u yeah, so c, actually here I don't think it's necessary to put that because that is being multiplied anyway, but in this case, if I had something like this, right, dot b, right, then in that case, inside, actually they had a dot here. Yeah, sorry, they had that, right? So in this case, I will have what? I will have this times this, and then this time along with this, because this is already telling me that this is already multiplied by, right? So basically this is just a copy over, just assuming that this is a coefficient of this. It's a parenthesis. All I gotta do is just multiply this, get rid of the parenthesis and write it U, actually not even, just CU dot B, right? And that will do that because dot B, right? So that is a dot right there, right? Okay, so with that being said, what can I say? If this is multiplied U, is it not the same if I move this up across here? So what they say is this is equivalent to, this here is equivalent to U dot V and C, right? So those are equivalent because I can actually move this C up front here and it's the same thing, right? So then they say number 4. So number 4, they say the following. On number 4, say that any zero dotted with V or U, whatever, is equal to 0, right? And then they say that just V dot V, just V dot V is equal to the magnitude of V squared. So if I multiply two vectors, right? So that will give me what? That will give me two vectors multiply each other here. It will give me the same, the vectors are the same. It will give me the magnitude of that vector. In the last video, we showed that this was the magnitude, right? So, so with that being said, we can actually work some problems out and see what we get, right? So they have right here some type of proof, but I'm not gonna go through this. I mean, it's just a proof of this magnitude right here. Okay, so let's do an example. Let's say that let's say that we are given a vector. Let's say that we're given a vector of vector U given actually, you know what? Just let me write as it is in the book. find that product. Find then the dot product given u equal to 2 comma negative 2 and v equal 5 comma 8 right, and c or w, I'm sorry, w is equal to vector negative 4 comma negative 3. Okay, so let's do this example, right? So so we know that we just do something like this, right? Similar, u, v, and w, right? I guess fair enough to say that we will dot this product, right? This times this plus this times this, right? And then that product, that along with dotted with this, right? With w, right? So first we will dot this and this, like I said. We basically, this rule will apply, right? So we'll do this, right? So basically with that 2 comma negative 2, right? And we dot it with, right? We dot this with what? With v, right? We're doing u dot v, right? So it's going to be equal to some number, right? So we have 5 comma 8. Okay, so we do this, right? So we do what? We do u dot v is equal to what? It's equal to 2 times 5, right? 2 times 5 plus negative 2 times what? Negative 2 times 8, right? So when I do that, let me erase this because I got a bunch of blue over here. Not gonna, probably the camera will be not able to zoom that, right? So now it's times 8. All right, so we do that, right? So we do that. 2 times 5 is 10, right? Plus this is going to be negative 16, right? Right? This times this is going to be negative 16. We add those together and we get what? We get negative 6, right? So that is u dot v, right? Now I gotta use this times what? Times the last term, which is this, right? This is w. So now I gotta do u dot v dot with what? Dotted with what? Okay, so or maybe this will make more sense. Actually, no, this is fine. So because I have a U dot V, right? So U dot V, right? Dotted with what? Dotted with W, right? Maybe the book did something different, but yeah, the book has this outside, but it's fine. I mean, it's the same thing. What the books did, what the book did, they just separate this differently. They did like this. Right? Just put the parentheses around this. Right? Put the parentheses around that, and just leave the W like that. Right? The same thing, pretty much. Right? So, same thing. Now we got it with, we got in U dot V dotted with what? W, correct? So U dot V was -6. That with what? W, which is what? -4, comma, -3. And hopefully I copied this number is correct. No. Nope, it's just 3. So, okay. Okay, so now when I dot those, I get what? When I do the dot product on this is equal to, this times this is equal to what? -6 times -4 plus -6 times 3. Okay, so now this U dot V dotted with W is equal to what? Is equal to this, which is going to be 24. Negative times a negative give you a positive. Positive 24, right? Positive 24 plus -18, right? -18, when I add those, I get what? I get +6. Right? I get +6. This, sorry. Let's see. This times this was 24. This times this was, say, is 18. And that will give me well, that just did it. Okay, so basically what they just did, they leave it as a vector. They did not add it together, right? So, okay, so let's do that. So this is what they did here. They left at 24, comma, 18. Right? So basically 18. Then then they took that, because that is part A, right? Actually, right here, this is one of the answers. This part A, right there. I can actually just do it right here. This is A, and this is part of part B. Part B is this one, right? So this is part B. And then part C, this is part B, right? And then part C, let me erase this. They have a bunch of different, and I would write them now here because I didn't. They have a couple different. So they have the following. So they say part A, do U dot V, which we already did here, right? U dot V give us that one. Then they say for part B, do U dot V dot W, right? Dot multiply with W, right? So notice when you don't have any dot like this, you get this type of answer, right? All right, so that is B. And then C, is U. One second. So on part C, I have U dot to V. That is part C, right? And in part D is just W, the magnitude of W, right? A square. Okay. So I already did V, A and B, right? Already did this. We need to do this. And notice what they asking for. They asking for the vector V 2 times, right? So they asking for vector V 2 times. So what is vector V? This is vector V. So they want us to do 2 times V, which is equal to 2 times 8, 2 times 5, comma 8. When we do the math here, we get what? We get 10, right? 10 plus 10. Actually, no. I'm just multiplying this twice. Multiplying this, and then that will be what? 2 times 5 is 10. 2 times 8 is 16. Alright? So I increased the number. What they did, just basically just multiply it by 2 with a factor of 2. I'm sorry. Multiply this number by a factor of 2, you get that, right? Okay. Okay, so now, but notice that in this case, they want to multiply that by U, right? So if I do that, I need to multiply this by U, right? So then what I do, what I do is I say u dot 2v is equal to what? Is equal to u. U is 4, negative 4 comma 3. So I got negative 4 comma 3 times 10 comma 16, right? Now I gotta do this. Now this is this one, right? This is this one. So now I gotta do what? This time this is negative 40, right? Plus. Now I am doing the real thing. Before I was not doing that, right? When I did it 2, I just multiplied that by the factor 2, I got that. Now I gotta do I gotta do this, right? Now I gotta do the dot product of this, right? Of the 2u dot with 2v. U dot 2v, right? So that's what I'm doing here. So now this, actually just let me do a step by step. So technically it's this, right? 4 times 10, right? Plus 3 times 16. So when I do that, I get what? I get negative 40 plus negative, positive 48, right? And that will give us a total of, of 8, right? So actually, no. They did something else here. Let's see. Okay. So I guess it makes sense what they did. All right, let me just reverse this. Let's do this again. This is what they did. Notice that when you look at it like this, right? And let me do this again because it makes sense with what they did. Okay, so this is what happened. If I factor out V out, right? Factor out V, let's say for example, right? Oh, factor out 2, right? What do I get? I get 2 times U dot V, right? Okay. So if that, with that being said, so 2 U dot V, right? Okay, so let's do this. So we notice when we did U dot V, right? We did this, right? So they did this. So when I did U dot V, I got a 6, right? I got 6. But I gotta do it again. I'm not gonna just write a 6. I will do it again because technically this is a different problem. Okay, so what we did here was the following, right? So we did U dot V. We did, because U is 2, right? And then so it'll be 2 times 5 times 5 plus negative 2 times 8 plus negative 2 times 8, right? Okay, so let's put this inside brackets like that, right? So we doing this operation and then we multiply that by 2. Let's see. Okay, so this is going to be equal to 2 times that. So this is going to be what? It's going to be 10. And this is going to be what? It's going to be negative 16. All right? So then we can say that u that v is equal to that, right? So now u that v is equal to, let me just do the math inside. So this is equal to negative 6. So negative, and then negative 6 times 2 is equal to negative 12. Negative 12. Okay. So that is part C. Now, let's do part D. Let's do D. All right, so let's do D, part D. So what they saying? They saying take this, take the magnitude and the square the magnitude, right? So, so this is, right, so this is equal to what? W is equal to 4, negative 4, negative 4, right? Negative 4 and 3, right? Negative 4. But remember, I am multiplying this twice, both of them. Multiplying this and this individually. So I am doing this. I am doing negative 4 times negative 4 plus 3 times negative 3 times 3. When I do this math, I get what? I get W squared, right, equal to 16. This time this is 16, right? And this time this is what? This time this is, and this is what they tell me, is that take each term of W and square it, right? In other words, multiply it by each term by itself. 4 multiplied by itself, 4 by 4, multiply negative 4 times negative 4 is equal to 16, plus 3 times 3 is 9. When I add those together, I get that W squared is equal to 25. So that is that one. Okay, so notice that in every single answer that we got, right? In every single answer that we got a number. We got a number. So we got a number here, also a number here. We got a number here, and also we got a number there. Every single one was a pure number, right? You don't have like magnitudes or like or V or or J or K. So that means that this is a pure number. So that product is basically addition multiplication and addition of a scalar, which is going to give you another scalar, right? So that's the dot product, right? So, so that's it, right? So that's it for today. I hope you enjoyed this video. If you enjoyed this video, please give me a like, share, and subscribe. Thank you for watching. God bless.